Hello and welcome to the Spack-O-Mat Kali Living Extended tutorial, which is included in the current Spack-O-Mat release. And this special thing I have a personal relation to, not only to Kali, who is a phenomenal guy from Argentina, who has worked on this formula for a very long time, and it is a really simple kaleidoscopic iterated function system. To get more info about this, please contact me either personally or research on the internet. This is not part of the tutorial. I'm as well using the hybrid definition for fractals. This is as well a hybrid fractal providing three array variations for deformation. And as you can see here, I'm just moving the Julia coordinate for the seed 1, and this leads to this deformation. The fractals in general is my personal liking, and the goal to achieve something phenomenal, a popular understanding of the chaos theory, is part of my being and well-being. So you find it under SOM-ST Living XT in the sources panel, which the shortings mean Spack-O-Mat, ShaderToy, Kali Living, and this is the extended version. The original Kali tutorial has an intrinsic animation applied to it, which will not be covered in this tutorial, but the parts are roughly the same, and you can play with this as you like. This fractal here has been extended to provide 3 seeds to animate. These 3 seeds are not just Julia seeds, but similar to the Mandelbrot effect, you can control various parameters. Before going to the general settings, I just want to inform you about what is going to come on you in the next few minutes. We have a seed consisting of a Julia coordinate. This time we have a 3-dimensional object, so we need 3 coordinates, the x, y and z coordinate. Additionally, 3 additional values can be configured for a seed, which is either for once the angle, and these azimuth and latitude controls actually control the axis around this angle is rotating around. This is part of the effect, and using very small steps for the angle leads to very fine graded structures. But all of the other angles lead to interesting results as well, and angles are repeatable by nature, which means when I put the timeline animation here, you have a smooth blending from the first to the last element, which is true for the azimuth and latitude as well. Azimuth and latitude are a polar spherical coordinate, but the latitude goes from 0 to 360 as well, which is usually not normal for spherical coordinates. So let me stop this and reset it to some pleasing stuff. The azimuth and longitude is used for the object inclination as well. So you can here in the upper parts above Julia, you have the Kali scale, which is an intrinsic parameter for this type of fractal, and it is not reflecting the scale of the general fractal. This is a parameter which you can use to animate and examine the effects of it as well. We have, as usual, we have the positional coordinates, and this time we have 3 coordinates x, y and z to position it where you like it. You can't control the light source. The light source is always coming from top, because I just wanted to reduce the amount of sliders you see here. You have the object scale, which is now the real scale for the element that is rendered. And you have, as I mentioned just before, the inclination and the elevation, which is derived from a spherical coordinate, providing you the two axes to rotate around, and both of them are repeatable. So the start and the end for achieving a nice rotation lookout, you would do it like this, and you don't need to map the envelopes of the controls, which could achieve various effects, but you don't need it for the basic variant of animation. So I have, well, in my long talk in the beginning, I said something about the Julia parts and the seeds. As you know, Spack-O-Mat provides you with as many controllable controls to achieve any visualization for music you would like to achieve. This many parameters, which all reflect on the original image, always lead to deformations of the fractal. Let me just shortly introduce the parameters. The Julia set is a constant factor that is added in the iteration. Similar to the money road is something constant that is added, and providing the three seeds, which I applied alternatively in the iteration loop, all of these become used. Although we have a very low iteration here, like just 25 iterations for this fractal. Compared to the money road, which uses like 128, it is a really low iteration count, but since it's 3D and ray matched, it has to be evaluated for every point in space, not only for every point on the plane. The Julia set so gives you a general scaling, you can say so. The negative values often leads to diminishing of the image, but you can cancel out the positive value from the previous one. You can achieve various interesting effects. Sometimes it is gone, but as you can see here, you should easily be able to restore a viewable part of the fractal by moving it to the positive part. This might be changing in the future, that you only can use the positive values, but this is the as-is situation, and we have to live with it until I make up my mind for another interface to make things easier. As I said, you have the main. Usually the fractal is controlled by a rotation angle about a specific axis. To reduce the number of parameters we have here, x, y, z, would be far too much to declare an axis in space, because you would have to incorporate additional normalization to make it a normal. And so I decided to use azimuth and latitude values for declaring an axis in space. We have the rotational end of the z-axis, and you have an elevation angle that then rotates around the y-axis, I think. Nevertheless, you're able to achieve any position on the sphere using these two sliders, which is just important for you when animating. These values, you don't want to animate the whole area here. The azimuth and latitude values are, in my point of view, best used when controlled in a really tiny area, where you have the control over what happens. And here we have a jump now, because we need to manually match the starting. Let's copy it. We need to manually match the starting and ending properties to get rid of that jump. As said before, I would not, you can do whatever you like, but keeping these areas in a strict range could be helpful. And this as well. The angle, this is the angle that is rotated by this axis defined by these two angles, is then executed in the iteration loop, which gives you always nice looking translations. What Kali did in his animated version of the original living Kali seawater creature, he had basically provided some kind of envelope, and he lets bounce the values in a yeah, like this, so that it's just going in the upper and lower parts. And as you can see here, you have a smooth animation which you can further then control by just rotating it, and we have now this, yeah, I don't know, it's a fox from, it's a fractal fox. And yeah, this is what I just put it to basic and make a nice setup here. This looks nice, and I change the inclination like this. So last but not least, we have the inner and outer colors, two color gradients that can be used to control the main and the secondary color. The highlights, you have to live with the white color, and just let me switch out this telephone, and I continue because I'm just finished here. So you have three seats. Each seat consists of a Julia part, which is an offset to be added, and an angle and an axis that is rotated around when this seat is used. So that's it for the Spack-O-Mat living tutorial. Enjoy and let me know if you like it.